Today we will create this particle effect with trails in Blender 3.6 using simulation nodes. I start by adding an empty object and renaming it to controller. To animate the empty, I enable the record button and move the empty in the scene while the animation is playing. This will record the empty's transform into keyframes. I'll adjust the keyframes a bit. Then, in the animation workspace, I select all keyframes and smooth them out. Animation seems a bit faster, so I scale up the keyframes, which increases the gap between keyframes. To smooth it out again. We animated the controller. This is where our particles going to emit from. To create the particle effect, I add a new mesh plane object, rename it and add a new geometry node setup. Pin the window as well. We don't need the input geometry, delete it. Now add a points node. To make it stick to the controller's empty, I drag and drop the controller object to the setup. Set it to relative and use its location for points position like this. I will increase the points count. Also, to randomize each point's position, I put vector math add node here, and for the second input, I use a random value node. This will add a random offset to each point's position. I set the min to -1 on all three axes. Then add a vector math scale node here to further control that offset amount. You can change this seed value to change the distribution. Now I'm going to put this into a simulation, so add a simulation zone to the setup. To spawn points every frame, I add a join geometry node here and plug our points into it. So when the loop runs, it will add 7 points to the scene every frame. This will create this trailing effect as well, which will be useful for us later. But right now, I like to randomize the distribution of the spawning points. At the moment, it looks very uniform. We can do that by plugging a scene time frame node into this seed value. It will change the seed value every frame, giving us a different distribution for the points. Much better than before. Now let's add some force to the particles to shoot them in all directions. For that, I add a set position node. We can change this offset value to add movement to the points in every frame. I plug a vector math add node. For the first input, I add a bit of downward movement to the points with a negative set value to mimic the gravity a bit. For the second value, I plug a scale node and a random value node. This will shoot the points like crazy. I set the min value to -1 to shoot the particles in every direction, and then use this scale value to control the strength. Play with the scale value and this set value to get an effect you like. Now I need to delete these points after some time, but before that I need to calculate their age first. It's very simple. Add a store attribute node. Set it to integer and create a new attribute called age. After that, add a name attribute node to get access to the attribute we just created. Then add 1 to it using add math node and plug that into store attribute. This will add 1 to the existing point's age for every frame giving us their age in frames. Now to delete the points after the simulation zone, I add a delete geometry node. Duplicate this named attribute node to get access to our calculated age. Plug compare greater than or equal node. And if our particle's age is greater than or equal to 15, I want to delete those particles. Let's increase it to 25. You can also plug a random value node to randomize that maximum age value. I keep it between 15 to 30. Increase the points amount a bit. Now to convert these points to something we can see in the render, I add an instance on points node and use a mesh 𝒔𝒄𝒊𝒂𝒍 as an instance. They are too big at the moment and I want to use the age we calculated to control their scale. So I duplicate it again and plug a map range node to it. Plug the maximum age into from max socket here. This will take our age and make a 0 to 1 gradient when points go from birth to death. I have to change the viewer domain to instance to see it. But since I want the particles to start big and then reach 0 scale at the death, I switch these two values. Now I add a multiply map node and plug its output into the instance scale. Change its value to reduce the maximum scale. To change the flow of the gradient, I put a float curve node in between these two nodes and adjust its curve shape. I give a bit of S-curve to it. Also, increase the icosphere subdivisions to 2. This will make it look more spherical. Let's add a globing material to this. I add a set material node. Create a new material here and assign it to the particles. Also, I am hoping to use this age gradient inside the shader editor, so I add another store attribute node and call it nAge for normalized age. Plug this float curve output to this value. Now in the shader editor for our particles material, delete the principal BSDF node. I can access our age gradient using input attribute node. Type the name exactly as you type in the geometry node editor. Since we are assigning the material to instances, in order to view the attribute, we need to change the type to instancer. I adjust the float curve a bit more. Back in the material, add an emission shader. Then drag from the factor and search for mix node. Plug it to mix factor and change the type to color. This way I can set two different colors for start and end of particles. I go with these two colors. Increase the strength. I can also use the same gradient with a multiply node for the emission strength as well. Change the renderer to Eevee and darken the world color. And here is our particle effect. By the way, if you are interested in procedural assets such as Engine FXs, I just released the latest update to Engine FX, which is now powered with simulation nodes. Use this coupon code before the end of 14th September to get 25% off from your purchase. Okay, let's create the trail effect. Since I have to use a lot of nodes I created here, I just duplicate the particles object. Rename it. Unpin this window and make a copy of the geometry node setup as well. Otherwise, you will overwrite the previous one. I call it trail. Now for this, I delete some nodes that we don't need. I remove the instances and this age gradient by hitting Ctrl X. I mute the delete geometry node for now. Remove these nodes as well. Set this offset to 0. Remove this random offset as well. Now when I hit play, we get this trail effect with points. Actually, we only need 1 point per frame. We can't have a random edge for this. Remove it and unmute the delete geometry node. I reduce this to 15. I want to add a bit of noisy offset to the particle's position. So add a noise texture. Plug a map range node and set 2 min values to -1. This helps to add noise to all directions. Then add a scale value and play with noise texture properties to find a good combination. Now what I'm going to do is I add a curve line node and assign these points positions to the points in the curve. By default, we get only 2 points in a curve line. But since we want to dynamically change the points amount, I add a resample curve node. To find the exact number of points in this sim, I drag from here and search for attribute statistic node. And for the attribute, I plug the index of the points. To find the maximum value of this index attribute, I drag from max, and since the index starts with 0, I add 1 to it to get the number of points in the simulation. Use that for points count here. Now I need to transfer the position data between these points in the sim and the points in the curve. And I can do that through their index. So I drag from here again and search for sample index node. For the index, I plug index node. We are looking for a vector value, position of the points. To assign this to the curve points, I add set position node and plug this into position. And here we have a trailing curve line. Right now it is not so smooth. Since we are dealing with curves, I like to use set spline type node to smooth these curves. Change the type to NURBS. This will smooth out the curves. To add thickness to this curve, I use curve to mesh node and use a curve circle for profile curve socket. Just like for our particles scale, I like this trail to have more thickness at the start. For that, I add set point radius node just before curve to mesh node. Since we're working with curves, we can use spline parameter factor to get a 0 to 1 gradient for the curve. I plug it like this and use this radius to control the maximum radius. For the material, I use this node but create a duplicate of the particle's material and assign that new one to the trail. Now in our trail material, we don't have anything for this attribute in the geometry node setup. Because of that, this material will not work for the trail. To create a similar effect for the trail, I can use this spline parameter inside the material. So I store it as a new attribute. Copy that name, go back to the material, change this back to geometry and paste the new attribute name. And just like that, our trail material is working as well. I tweak these values just a bit. And that's almost it. But since I like to have multiple trails, I am going to extract this maximum H value using a group input node. Also set the noise to 4D and extract this W value as well. Now in the modifiers tab, I can change these two values to change the length and the noise. So I duplicate the trail object and change those two values. And here we have two trails which are different in length and displacement. I duplicate this one more time to have three trails. And just like that, I created this simple particle trailing effect inside Blender 3.6 using simulation nodes. If you'd like to see a bit more advanced geometry nodes effects, check these videos out. And don't forget to check out Engine FX with this coupon code before the end of 14th September to get 25% off from your purchase. Until next time,